Welcome. All right, let's get everything situated. Today we're going to work on not this maze solver, but the audulus canvas library. There we go. And let's see, it's been a couple days since I've worked on the canvas library because I was getting sidetracked by the DSP library that I all of a sudden got inspired to work on. So I'm going to see where I can jump back in here. Okay, you can see I'm a lot further along on this one than the DSP library. I've been working on this for a little longer. At a certain point, I was building things up and I'd gotten to like triangle, and I was like, wait a second. Like I didn't really like fleshed out point or line, and I had to go back. And so I'm trying to do one thing at a time and really kind of complete each class as I go. Because if I just sort of half-assed everyone as I'm going along, then it's a lot of work to go back and kind of top off each one. So what I have here is the canvas node, and there's a lot more code. As you can see, we've got 2,000 some lines before this, and you know what I'm doing is every time, oops, here, build library, right? And I was doing this in the other example as well. What this build library command does is it concatenates all of these files together into one file, and then I can copy and paste this into the window. Make sure I have the latest version. Oops, and I accidentally did it at the wrong point. There we go. And here I'm creating an origin class, and what this does is it creates kind of an origin point here and shifts the coordinates around this point. So right now the origin is at the center of this window of the canvas node, and then I call reset back here, because if I don't call this, it actually shifts everything over, and I want to have that little print statement at the bottom here be kind of underneath the window, and you can see how that print statement works. You could just do print, right? And I actually had to implement this from scratch because I needed some kind of debugging tool so I could see what was happening in the values and not just the visual output. So I could, so this is super helpful, and you'll see me use it quite often when developing this library. Okay, and I took this out of another patch, and I need to reset it to something actually. So we need a timer node. This helps generate the memory usage over time. And I'll group this and just set this to time. There we go. And set that on top of the canvas. Okay. Back down here. So I have these little to-dos scattered here. Okay. Do we need this intermediary private color table? And I'm wondering that myself. Let me come back to that because that's not the most interesting thing to start with. Close all these windows on this side. Okay. With the line, I think the line class is pretty much done. I think I might need to, yeah. I think so. LineGroup now. Is point done? Add docs, yeah. Of course, I'll do that towards the end. Each of these each of these classes. So have a docs method that you can call in them. And how did I do this? Oh, did I just not add docs at all to here? Yeah, I guess it didn't. Okay. Here, let's do back. Yeah. So this is a little shortcut for vec2. You can just type v if you want. And I'm creating a new vec2 class is just like a point. And you can call the docs method on any of these instances, and it'll print out the documents for that class. So you can see there's a lot of stuff you can do for vec2. Right. And I just thought that would be to have the documentation inside of audulus for just quick little things you want to look up, rather than having it in a separate window, especially if you're on iPad. It's not always necessarily as easy to have a second window up with audulus running if you don't have a huge screen. Okay, so I'm having a little late start this morning. Okay, line graph. The line group. So we need to make some points here. So first, vec2s. Okay. Yeah. So XY array. We'll see how we construct these. I'm going to make an array of XY points. So I'll do one, let's see, let's do 0, 0, and then 10, 10. This is like X and Y. Each of them is a coordinate. 10, 10. Actually, let's do size. Just so we can do equals, just so we can resize them dynamically. And then SS negative S S S negative S, doing all the different combinations, and negative S S. Okay, that's right. That's 1, 2, 3, 4. Negative S, negative S. Right. Okay. And now we're going to create. We're going to go to the factory. I'm going to remind myself how this works. Yeah. Okay. So. Vec2s equals. I will. Yeah, so again, you can do the shortcut instead of just having to type out the whole factory. Factory dot vec2 and then xy array. Where is this? 2,852. Oh, dot new. Okay. So then that should create a bunch of vec2 objects out of each of these arguments. So it's the same as like vec calling this the vec2.new over and over on each of them. So you do like xy array 1. So that's this here is the same as if I were doing this over and over again and then packing them into a new table. This is just sort of iterating through the table and turning each of these into a vec2. Okay. So, and I want to do this, so I want to create a line group for going over these methods here that I'm going to add. And then okay, vec2s. So line group equals g.new vec2s. So you can see now we drew, these are the points, and there's that one in the middle. And we're going to do 100. Put that out. And if I move this point in the center towards the side, you'll see that it's actually there. It's separate from the other ones. Maybe I should just for the sake, yeah, just have 4. So these are going through. And what it does by default is it draws between all of the points. And that would be, I'm trying to find more specific names for these things. So graph is actually a more like complete, like a version of like what this is. It's a mathematical term or a programming term. We have these points that you're making connections between. So, okay, so I'm gonna first rename this as draw between. So, okay, yeah. So draw between is going to rename symbol. Graph. Did that work? Yeah, okay. And then from to is actually a star. So that's another name. Star. Equals graph. Star. Okay. So excuse me. And I believe with the from to, it actually does the, like this star. Yeah, it takes the first one and then draws a line. So every line, it's starting here and then drawing to the next line in this. But I just realized I'm actually kind of drawing one line here first. That. 2. Okay. Yeah. That was a good catch that I found. So I was actually in the first iteration of this star. Okay, let me show you what the star does first. Okay. So we go to groups and then we're going to do options. There's a little lag in this because of just how many lines of code there are in there. So often it's another reason that I have VS Code open here and copy and paste in here. It's because of the way that Taylor is using this open source version code editor that he plopped in here. Actually, every character that you write, it actually redraws everything in the whole editor. So there's a ton of text it has to move over every single time. Okay, options. So I was going to go do style equals, oops, there we go, star. Right, what did I do? Hold on. It's been a second since I did this. Okay. Oh, method. Yeah. It's the method line. The style is what the line looks like. Method. Yes, of course I didn't paste this over yet. Build. And paste over. There we go. Okay. So as you can see, that is, whoops. Maybe I can do, screen a little bigger here. So this is the first point, and then it's drawing to these other points out over here. So that's the star method, and then we do graph method. Is in between all of the points. Star. So that works. Okay, star, graph. Okay. Polyline. What is grid? What was I thinking of grid? triangulation. I know the triangulation is going to be a fun one. You can kind of, I'll talk about that in a sec, but let's implement polyline. Because what we want to do for a polyline is get a series of vec2s, so like draw a line from here to here, then from here to here, then from here to here. Because right now, this is it's drawing from here to here, here to here, here to here. And then a graph would be here, 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 and then here, 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 here. Okay. So, okay, polyline. I try to keep the functions alphabetical. Space in the code editor again. Okay. Yeah, so I equals 1 to the self dot 2 is due. You always want to do, I always forget this because you have like, yeah, you start from 2, but then you do I minus 1 for the first one. That's how you avoid the index error. Right? And then the other one is I. Yeah. That was a good trick I learned recently. Self-type options. Okay. I feel, here we go. This is another, I realize that this is a repeated bit of code I could probably break out into a function. For now, for just this moment, while we get this working, let's do this. Okay. I think this will work. Just like that. Let's try that. Oh, whoops. I forgot to put in the draw. Where's the method? Okay, yeah. If self.method equals polyline. Self.polyline. Oh, whoops. Double equals. Okay. Polyline. Nice. There we go. So it's going from this line, this point to this point to this point to this point, and we can improve that. So, and it's going in order, right? This is SS minus SS, and then down here. So then we'll do to like 10, 10, right? Let's see, it immediately goes to 0, 0. So 10 and then 10, right? Negative 10. So that's cool. That's nice. All right. Okay. So we implemented that. Now let's break out this nonsense here. Okay. Okay. I do self.style. Okay. What do I call this? Because there's always draw, and I want to draw this line. So like, yeah, I just call draw line probably. So LineGroup draw line. This would be sort of a private function. I haven't thought of that. Making functions private by putting like underscores there, but that might be a little. That's like maybe a finishing touch for later. So draw a line. I'm still kind of like working on the style. Yeah. So, where is this coming from? Why am I getting an error here? Undefined global line. Oh, of course, yeah, because then we need the line. Because we want to define how the line is drawn here, and then just pop it into this. So let's try that. And then, so self.draw line. And see, that cuts down a lot of code there. Let's just make sure that that works before we go copy pasting and everything else. Yep, looks like it. Put this in the right alphabetical order: A, B, C, D, E, F, G. Let's do it. And now we can just call that inside there, getting rid of some repetitive code. Okay, and that makes it easier to just look at the function too and figure out what's actually going on. Okay, internally here there. So I mean, isn't this a little easier to understand? Okay, this is the graph, this is the polyline star. You can sort of grok what is happening a lot easier without this distracting other code that is underneath all these. Okay. And what I mean by like a private function, because like you're never going to use this LineGroup draw line function, so you really should like put a little underscore before it. But I will not mess around with that yet. And when I'm getting close to the end of the 1.0, I will, the 1.0 release of this library, I will go through and kind of take a pass at like the style of everything to kind of get them all lined up. So, okay. Let me see. New window. Now, there's this kind of, what was I thinking with the grid? I just wrote that down and I should have explained it a little more. Grid. Okay. So, I went the other day and was like explaining this class to ChatGPT and asking like, what are some other cool ways to draw lines in groups? Because this is, the line class just draws a line in between 2 points. And the line group is you send this collection of vec2s and do something interesting between them. And one of them was this one's going to be harder to implement, I know, is that you can imagine you have like a random grouping of vec2s, and then you draw triangles within them between the like closest points. You've definitely seen this before, so like let me see what it's called. Okay. I don't know what the grid is, so I'll just move on to the triangulation then. I'm just going to give it the context of this code. So, implement a method that calculates triangles between vec2s. I forget what this is called. It's very neighbors. Okay. Yeah, Delani. Okay. With triangulation. This thing. So you've seen it before in lots of things where you have these points and just you draw triangles between these closest neighbors. Was this the other thing? Maybe this was the... There's Delani and Voronoi. It's sort of like the inverse of each other. I think the Voronoi is just like bubble diagrams. You see like yeah. Okay. So let's just look at Delani triangulation on Wikipedia first. Delani criterion. Okay, let's someone explaining it here. So you can see the difference here. You can do triangulation this way, but this doesn't look as nice as this, the kind of optimal, where I guess each line is the shortest as it could be. Okay. Okay, so one big triangle. What is the circumcircle? That was this thing, the circumcircle. Okay, the circumcircle is this part. Okay, so you create a super triangle. Well, I need a whole other method for that. Okay, this is one of those where maybe I have to do a little more research that might be less interesting while I'm streaming to just kind of figure this out. Oh, I forgot I don't have the chat up. Let's see. Let's see if anyone's here. I'm streaming at a weird time, both for me and for other people in the US, so don't blame you if you're not up this late on, I guess it's Friday. You'd be in, let's see, my channel, looking on my phone. One viewer. Is there someone actually here, or is this just, you know, the one viewer is me? I don't know. Sorry, this is a little boring to someone watching the replay. You can just skip ahead a little bit. Where is this chat? My channel. There is the chat. Okay. Okay. What's there? Move this up. Just in case anyone says something. So I'll come back to these ones. What is the grid? What was the grid? Maybe. Oh, I think I know what I was doing. Like, given 2 points, maybe that you draw in between. That means, yeah. So So I was thinking maybe like you draw a grid of lines, and probably I was probably thinking you have 2 points that you're making a square, and then you know, I'll come back to this. I did that, so get rid of these. Excuse me. Okay. I think I need to make another pass at origin. So here's graph. I was setting this on. Step color. Yeah, maybe I should just. This is one of the first things I did, so I hadn't implemented some other things in it yet. Okay. Yeah, let's do graph. Okay, so if we wanted to do graph, we're going to take the first 2 points, and so let's just make those negative s, and ss. Okay. And then there we go. Okay, so I'm gonna do this on this array just to have a sanity check that I'm gonna take just the first 2 and then ignore the rest, because we're going to use options we're gonna draw a graph here and use the options to draw what the step is in between each of these. Yeah. Yeah, okay. Okay. Well, that's a graph. What did I? Grid. I was thinking grid. That's going to be a little confusing, but that's okay. Okay, so I'll be right back. Okay. See? Make a grid. So, to think about this. Yeah, I need to draw this out. I know I promised yesterday that I would have something to draw on the computer, but I didn't look that up. So I'm just going to do this on paper again. You have to bear with me. I'll just talk you through it, or you can just skip forward a little bit. Okay, so I have this point x1, y1, and that's the lower left point, and the upper right point is x2, y2. And I suppose graphics programs are supposed to be from the top left down, and maybe I should do a refactor at some point to do that, but my brain just doesn't work like that, and it's tough to think in that way. Okay, so y1, and then what I want to do is have like a number of lines in between them. So then I have to take, if we have the number of lines, so if there's 1 line, 2 line, 3 line, 4 line, 5 lines. So then I'm drawing vertical lines now. So this is x1, y2. So for the vertical lines, I have this little space, which is 1, 2, 3, 4. So that is the difference of x2 minus x1. x2 minus x1. I want to take the absolute value of that too, probably. I don't know. Let's not worry about that right now. x2 minus y1, or x2 minus x1. That is the space in between each one. Yeah, let's see if we can get it drawing the vertical lines. Okay, so we're just going to do hard code the number of repetitions right now. So 4 do. Okay. Self dot for something like a equals x2's 1, and then 2. Okay. Let's do PA. Let's do back 2. Make it explicit. Okay, so I'll take back 2a. Line equals, let's just copy and paste this. So we're going from back 2a. I need to construct every time a new vec2 from this, because we're interpolating between these two. So v1 equals 2a. Wait, I want to go to 0. Wait, is that right? Here. Yes, 0 to 4. V1. V1, V2. want to start at the bottom. Should I start at the bottom point or the top point? Yeah, the bottom point. So vec2a x, vec2a y for y, and then vec2a vec2 dot x, vec2 a dot x, but then vec2b dot y. Because we have a line that we're drawing, and then we're starting down here, like starting down here, and we want to draw up to this line. So if these are the 2 points, then we have to create a new vector that is, starts from this vector and then goes to this new constructed vector up here, so here to there. But then we're going to draw like this across. So each iteration we need to create a new set of vectors across. Okay. And then we're moving over, the y's are staying the same, but the x's are moving over by the difference. We need to find the difference between xd equals vec2a dot a dot x minus 2a dot x. Okay, that's the delta between these two and the y delta. Y. This is the distance between these 2 points. And these two different coordinates. So we're going to do x, d, but we need, the y's are staying the same, but the x's are increasing. So we do, let's just go ahead and pre-calculate the iterations, because we don't need to do the division on every single line. So let's say because we're going to have this as a what's it called? One of these things. So this is a option, yeah. But we're hard coding it right now, just for the sake of ease. Okay, so iters equals 3. Then we're going to calculate x space equals xd divided by 3. Okay. And then y space iteration. X space. Okay. Line and then line. Oops. Let's try this. Then, forgot to add to the methods. So, if method equals, what were we doing here? What's this called? Grid. Nope. Okay. What are we doing wrong here? Oh my god, yeah, I forgot to add the iteration in there. Times I. Times I. There we go. Excellent. Okay. So horizontal 1, 2, 0, horizontal lines, so that's also going to start at x1, y1. So vec2a dot x. Yes, so vec2b dot x. Wait, what am I doing? Okay, no. And then vec2 y, yes, but then time plus y space times I, and doing h2, this is for vertical and horizontal, y space, so then vec2b. This is a little confusing. Okay. And I want the line to be going up, and then, yes, it starts from this point, and it's drawn to this point. Right? Is that right? Okay. H1. H2. Same thing somehow. No, I didn't have good. Because it's like drawing in the same x coordinate. Okay, hold on. Vec2. Okay, if we're starting at this bottom, that's vec2a x. Vec2a y, and then if we're going here, that's vec2a, that's vec2bx, vec2a y. Yeah, okay, that's what it is. Yeah, there we go. Hell yeah. Okay, so we can do, let's see, 10. Excellent, there we go. Perfect. Okay. So let's do style. Style equals let's do dotted. There we go. Cool. So each lines have different styles to them. We do normal, dash, dotted, and character. So we do dashed. Okay, dash works. And then character, which uses a character to draw. So in this case, a plus. So defaults to normal. Excellent. So we implemented this. Now we need to do this where we do split right. And how do we do it? So line.styles. Oof, okay, so the options. Now this is interesting because what I want to do is add an attribute for the grid that is how many iterations you want to do. But the problem is, I don't want it to be attached to every single new instance of the line group. I want it to only be in the line groups that have grid as one of their options, or as their method. Oh yeah, I had to change this to method to be graph. How do I do this? Maybe I just do. How this utils function works. It just looks for that self property. Okay. How do I do this? Because I could just easily add it to the constructor. Yeah, iterations. But then it doesn't seem as clean, so. For right now, let's just do this just for, so iters. Options, iters for 10. Then we'll go down to graph. Nope, not graph grid. And then we'll place this. Place this. That should work. Yeah, okay. So then iters equals 100. I was about to put a comma there. Yep, see, we have 100 little lines being drawn there. Okay, 10, let's see, 20. Let's make this color a little nicer. Color equals C. G. Let's do gradient.new C dot red. Let's see. Choose 1. Choose 2. I'm creating a gradient here between these two. Colors C dot blue. Did I not construct the gradient correctly? Vector B. Oh, 2. That seems like it should be right. Let's do Why isn't this gradient working? So G new 2 is 1, 2 is 2, and C dot red, C dot blue. What's going on here? Do I not have... Okay. Oh, of course. I think I have to do gradient here. Gradient. Yes, there we go. Okay, that confused me. Okay, but that seemed to be like the error message. Seemed to say, yeah, expect a color insert color table. Then we do gradient. There we go. That's nice. So, see, I don't want this iters just attached to every single new line object. LineGroup object. Let's see, do LineGroup. Did I do print for this? I did, yeah. Because see, even if I do normal. Wait, not the method. Let's do graph. That iters is still. Oh, is it not? No, because I didn't put it in the print method, but it would still be there in that object. Okay, grid. All right, how am I going to it's got to be something like this, or like if the method, yeah, do I just have to do methods like styles, or I think I do, yeah. Okay. And methods equals this. So graph equals yeah, so then, okay, so if the method is graph, then the iters is 10. And then I have to go into the utility function and add this in there because we need to. If class.styles, then methods. Oh, but what if it doesn't have a... Yeah, no, because... Let's do empty string there. Yeah, no, do this. Rocket method, local method val equals class.methods method and key. Okay. If method val does not equal null, then return method val. Okay, I don't know if this will work. Oh, did I forget an end? Yes, I did. End. End. Okay. Okay. Let's attempt to index a nil value. That is because method not no. Wrap this. Oops. Okay, let's ask ChatGPT what I'm going to hear that's wrong. Okay. Okay. I want the iter's property to only exist on the instance if instance is about instance is uses the method grid. Let's do grid. Let's get the context here. I know I need to alter my resolve method, but I've been doing it wrong. Okay, I'll be back. back up. On the small chance that someone comes in. Okay. Okay. What did you change your methods? I don't know if this is correct. How is this significantly different from what I'm doing? Don't think it is. Do I just need to... I don't think, any of these... They don't need separate methods, but whatever. Let's just see if this works for some reason. I don't think this will make a difference, but to do graph. Wait, no, graph. Grid. Oh my god. Maybe that was it. Okay. See, that it is confusing. Okay, attempt to index a nil value. Whoops. Okay. I just have to do default like this. Default equals whatever. Or default. No, okay, that doesn't work. Okay. Should I just... Part of me just wants to just leave the... It's just a number. is this significantly different? What's going on here? Okay, so we're getting, if the class has methods, right, as an attribute, then we're getting the, from the instance, the value assigned to method, or we're defaulting to default, right? Because I don't want to do this. Okay, so this, if the method is nil, this could be nil, right? Then we just skip, right? And then if method is not nil, then we try to get the method val from class.methods .method, or method, and then the key. Where am I getting the key from? Instance key result property. How am I doing this? Self.options. So that's the key. Value is rocket instance key. Okay. Yeah, let's ask for help here. So the same as class.styles functions correctly. The issue is that that in LineGroup, that needs an extra property is grid. Iterations, okay. Should I do X and Y independently? What purpose would that serve? I don't know, maybe.
gracefully by checking the method supports the property before trying to access it. Class.styles, class methods. Instance method. Method's not nil. Oh, okay. And class.methods method. Okay. Yeah, that would make more sense. Yes, okay. Excellent. Okay. Good. And we're going to do method equals grid. Oh yeah, okay. But now let's do, okay, I think I just solved this. So print, ChatGPT helped me solve it. So I'm gonna look for on this. Method is grid style. This is the whole object, and I'm going out to look for errors, right? Because it should be on here. Hold on. Close this. Grid. Yeah, method equals grid. This is a huge object. Okay, I didn't see it, but it's there somewhere. Hold on. Oh, why didn't I do this? Yeah, of course. Yeah, because I can do LG dot right, grid dot method dot errors 10. And so if I change this, this will error it will be a nil or something. If I change this to get rid of the method, because it will default. No, that shouldn't be working. Errors. See, it's assigning it even if it is, which is the whole point that we don't, because I didn't take it out of here. I'm dope. Okay. There we go. Perfect. Okay, that's what we want. Okay. Because we don't want this property to be present on this object unless the method is drumroll please, grid. There we go. Okay. So iters equals 100. There we go. 50. That looks fine. Okay. Excellent. Okay, I think that resolves that. But then now I need to go down to the print, and then if style is. Method equals grid down. Okay, and then we do method. Method equals method. Yeah, okay. Okay. Am I not printing the method out?
do that up here? That's style, okay. I don't think I'm printing method anywhere. All right, so method equals string self.method. Wait, I don't need to do string because it's already a string. Self.method. I think for that. Great. Do we need to? Or not? That's just 2 spaces. I did 4 there. Okay. Okay, method. Let's get rid of these. Graph. Great, there, perfect. Okay, we implemented that. Okay, because now that in the line group that prints all of the attributes correctly, because you don't want this iters to be there if it's not on the grid. Now, do I want to do X and Y separately? I think we do. Just why not? Because we can. But then let's do this later because I did grid. I'm a little sick of this right now. I'll come back to it at some point. Let's do like X X iters and iters default if Y isn't specified. Because I want to have X and Y separately so you can have a different number of iterations going this way and this way. But I want also that if you only specify one of them, that then it just uses the other one for both of them. Or maybe there's just a default value for both. Maybe there is. No, because I want if you just specify iters, then yeah, I'll just do this later. Okay, think about it later. Okay, good thing that's working now. Great. Great. Okay, can I simplify this at all? This looks messy. I don't think so. Okay. You know, I think I'll call it there for today. That was a good what I added onto this. I like this little arrow that I added there. That's nice. This color to this color.
Okay, all right. Thanks for joining me. I will see you tomorrow. Peace.